Welcome to Discovering Geometry with Mrs. Berry. This is Lesson 7. We're about to learn something that you encounter every day, unless maybe you stayed in bed all day. It's circles. Today we'll talk about what a circle is, arcs, congruent and concentric circles, chords, diameters, and tangents. So let's get started. What is a circle? A circle is a set of all points in a plane that are at a given distance, that'd be the radius, from a given point, the center, in the plane. Look at this video. There's a dot in the center. And watch as we use this compass and turn the paper. We're drawing the points that are an equal distance. This length between the center and the drawing pencil, that is an equal distance. It's a given distance from that point in the center. And when you're finished, you will find that you have a complete circle. We name a circle by its center. This circle right here is circle O, because O is the center. If you see, every radius is the same length and it can go out in any direction to the edge of the circle. So what are the radius and diameter? The radius is the segment from the center to a point on the edge of the circle. We will also sometimes call its length a radius. That distance is the radius on the circle. Here's a picture of a radius. It's from the center out, so it's really only half the distance across the entire circle. A diameter is a line segment containing the center with its endpoints on the circle. So its length is also called a diameter. Here's a picture of a diameter. Do you see it goes all the way across a circle? And there can be many diameters in this circle. We could have a diameter from this side. If we start on this side and go through the center, this would be a diameter. Any line segment that goes through the center that starts on and finishes on the circle, that would be a diameter. What about congruent and concentric circles? A congruent circle is two or more coplanar circles that share the same radius. So let's think about that. They have the same size because their radius is the same. They have the same shape because they're both circles. So that means they're congruent. Here's a picture of congruent circles. Here, AB is the same length as A1, B1. So these two circles are congruent. Down at the bottom, these smaller circles, A2, B2, is the length of one radius, and A3, B3 is a congruent radius on this circle. Both of these are the same shape, they're both circles, and they're both the same size because their radius is the same. What about concentric circles? Concentric circles are two or more coplanar circles that share the same center. If we look at this rainbow circles up here, all of these circles have this same center. So the blue one and the yellow and the green and the purple, they all share that center. What are some real life examples of concentric circles? Can you think of some? What about playing darts or a wheel and axle, the rings of a wood tree, or an archery target? All of those have concentric circles. They share the same center. Even a ripple in a pond could be somewhat concentric circles. An arc of a circle is 2 points on the circle and the continuous, that would be the unbroken part, of the circle between the 2 points. We call the 2 points endpoints of the arc. Here's a circle, and now I'm going to draw in red an arc. Do you see that this arc starts here and ends here? These would be the two endpoints of the arc. If I labeled this A and B, this would be arc AB. We could also write it as AB with an arc symbol over it. It's just part of the edge of the circle, not the whole thing. The arc is part of it. There are different kinds of arcs. We have a semicircle. That's an arc of a circle whose endpoints are also the endpoints of a diameter. That would mean that you're going to get exactly half the circle. Semi means half, so semicircle would be half of the circle. A minor arc is an arc of a circle that is smaller than a semicircle. And a major arc is an arc that is greater than a semicircle. Let's look at this example and see if we can find some. If O is the center, XO is a radius, and YO is a radius, OB is a radius, and OA is a radius, and so AB goes all the way across. AB would be a diameter. If AB is a diameter, then this arc over here could be a semicircle. When we label a semicircle, we're going to go ahead and label it to know that it's this top half instead of the bottom half. We don't just use arc AB. We're going to want to do one other point in between. So the semicircle that I drew is ALB. It would be arc ALB. I've labeled it with another letter in between A and B because arc AB could also go this direction. If I wanted to label a second semicircle, I could label it AXB, or I could label this same AXB arc as AYB. I just have to pick any letter, any point in between my endpoints to label it with 3 points. A minor arc, I could pick any of these smaller ones, AL, LB, BY, YX. I could go BX or AX. Any of those are going to be smaller than a semicircle. So I'm going to say that AX is a minor arc in this circle. A major arc, I'm going to need, again, 3 letters because AX, I could say that it's a minor arc if I go the other direction. So A all the way around to X could be a major arc if I pick another letter in between to differentiate it from this small minor arc of AX. So if I labeled ALX as an arc, that would be the one from A through L all the way back around to X. How do we measure arcs? Well, arcs have degree measures just like angles do. A full circle has a measure of 360 degrees. So from one point all the way around the circle back to that same point is going to be 360 degrees. So what do you think a semicircle is going to measure? Remember, the semicircle is exactly half the circle. So its measurement should be cut in half. That's right. A semicircle is 180 degrees. Let's look at how we could measure any arc. Arc AB is 82 degrees. It actually matches what this central angle is showing. This central angle is also 82 degrees. It's almost a right angle, but not quite. So we can find the arc measure by measuring the central angle. That is the angle with its vertex on the center. And its sides pass through the endpoints of this arc. So our angle AOB is going to measure the same as our arc AB does. So our measure of angle AOB is going to be equal to the measure of of the measure of arc AB. In this picture, the arc AB is equal to 82 degrees. What about if we drew the major arc around ADB? What is arc ADB going to measure? Hopefully you can do it without a protractor. Remember, the entire circle is 360. So ADB will be 360 degrees minus the part that we took out over here of AB. So what will we have for the measure of angle ADB? You should have gotten 278 degrees. That's what ADB is on this side of the circle. So we have a minor arc AB and a major arc ADB. What is a chord? Now we're going to have to come up with our own good definitions for these terms. What do we see over here in these pictures of good chords and these that are not chords? AB is a chord, DC, EF, GH, and IJ. But RS is not, and PQ is not. TU, this arc, is not, and VW is not. What definition can we give for a chord? Well, I can see that all of these listed are line segments. We can see the way they're written as line segments. This one is an arc symbol right here, and this one is a line symbol. So I know that it's a line segment. Why isn't PQ or RS a chord? How are they different than over here? Where do we see the endpoints of the chords? On the circle. That's right. So a chord is a line segment joining any 2 points on the edge or on the actual circle. We'll learn more about the circumference later, but that is the edge of the circle. All the way around is the circumference. What is a diameter? We have nice, pretty spoke wheels here, or spokes on a wheel. AB is a diameter, and CD is a diameter, and EF is a diameter. But over here, PQ is not, and RS is not, and TU is not, and WV is not. So remember, we went over this at the beginning of the lesson. We definitely see the diameters are line segments. They start and end on the circle, but what makes them different from a chord? They pass through the center. So a diameter is a line segment containing the center with its endpoints on the edge of the circle. Last definition for today, what is a tangent? EF is a tangent, and AB and CD. PQ is not, and RS is not, and TU is not, and VW is not. I'm seeing that all of the tangents are lines, not line segments this time. And what makes PQ not a tangent, but EF is? How many times do you see the tangent line touch the circle? A tangent is a line, not a line segment, that touches the edge of the circle at exactly 1 point. It could also be said that a line that intersects a circle at exactly 1 point is a tangent. We will learn more about tangents, but I want to point out that the point where a tangent touches the circle So in this case, CD is a tangent to this circle and it touches at C. C is called the point of tangency. It's where it touches the circle. A couple follow-up questions to get you thinking. Can a chord be a diameter? What was our definition of a chord? Remember, a chord would just had its endpoints on the circle. So I think that a chord could be a diameter, but not all chords are diameters. Can a chord be a tangent? Remember, a chord was a line segment that touched the circle twice because its endpoints were on the circle. A tangent was a line that intersects with the circle only once. So no, a chord and a tangent could not be the same. Can two circles be tangent to the same line at the same point? Let's see if we can draw that. Here's one circle, and I'm going to make its tangent right here. And it intersects at this point. Could I make another circle that uses the same point of tangency and the same tangent line? I sure could. I could make it on this side, or I could even make it on the inside. Remember, these are not concentric circles because they don't share the center point, but they are inside one of another. So yes, we could have two circles being tangent to the same line at the same point. Don't forget to do your homework and also make sure that you're keeping your binder with your notes and your homework very organized. See you next time.